about our study, how we're going to do that. So, all right. Let me know when you guys are ready.
I'm ready.
Nope, go ahead.
I'm ready. Should we start with number 3?
Yes.
Okay. The symbol for true population portion is which of the following? It's just the regular P, right?
Mm.
Yeah.
Okay. For the next 2 questions, suppose that n is 100 and that p is 0.25 and that population p hat is equal to 0.10. The requirements for constructing a confident interval are satisfied. Okay, so this is where like I missed one on the homework quiz. Am I using the p hat or am I using the regular p to figure out whether it's satisfied or not? So what do you guys say? This is the part like I was like, is this the one where I take the 0.25 and I times that by n and greater than or equal to 10? So if I do that.
The P hat, is it a P hat or is there 2?
Well, there's a P and then there's a P hat. So P is 0.25 and P hat is 0.10.
No, but like on the video, when it says like the requirement to check.
Yeah.
So what I seen here on the part 2 video, it says the P hat. So is there one with just regular P?
Well, yes, in the beginning, like lesson 16. When I took the quiz, I chose the P hat and it had the, the N times P is greater than or equal to 10 and N times 1 minus P. I chose the P hat one versus the P and I got it wrong. So then I was like, oh, am I not supposed to use the P hat? Or am I just supposed to use P unless I don't know. That's where I get confused right now. So what do you guys think? For this question number 4, requirements for constructing a confidence interval are satisfied. We do 100 point times 0.5 equals 25. And if we did, I mean, either way, I guess it's okay because 10 times 10 is 10 times 100. Equal to.
True.
You guys tell me, is that? Calculator out. I will lead you astray tonight.
Let's go true.
Okay, I'll go with true with you on that one. True. Okay. The requirements for conducting a hypothesis test are satisfied. Okay, I think this is where the difference is. Like one of them is
this is the regular P.
This one is the regular P?
Yeah.
Yeah.
Okay. So hypothesis test is regular P. I'm going to write that down. But the other one, confident interval, is the N P with a hat, the test.
Mm-hmm.
Okay. Let's go true there because I did that one, figured it out. That one's true. Okay, use the following information for the next 5 questions. Okay, so we have a random sample of 60 people on trial for first-degree murder. Of these, 45 defendants were found guilty. Okay, find P, the point estimate of the proportion of the first-degree murder defendants who were found guilty in this state. So we're just going to do 45 divided by 60, right?
Mhm.
And that's 0.75.
Yeah.
Oops.
Okay.
Okay, so create a 95% confidence interval for the true proportion of the first-degree murder trials in this state. There is a verdict of guilty. Put in your answers for the margin of error, lower and upper bound. So determine margin of error for this 95% confident interval. So how are you going to solve that?
Isn't there's a formula for it?
There is. Are you going to use the M equals Z times P hat? Times the 1 minus P hat divided by the number. It's like standard deviation times Z score. So if it's 95, it'd be 1.96, right? And if we're using the proportion would be 0.75. Divided by 60. Okay, so I got 0.1095, which would round up to the 9 would be 10, and so it'd be like 0.11.
Yeah. 0. Yeah.
Is that what the rest of you got?
0.11.
Yeah. So if we add that, right, because now we're going to take that.
For 7?
So for 7 is 0.110, right, margin of error. And if we do the lower bound, we'll take that and subtract 0.75 minus. So my lower bound that I'm coming up with is 0.640. Okay, what did you guys get for 8?
$6,404.
Okay, that's what I got, and then I just dropped the 4.
0.640.
Yeah, 0.64.
0.
Throw a 0 on the end, I guess. Okay, so the upper bound. So 0.8595, which then would round over.
0.860.
Yeah. Why can I get these answers with you guys, but I can't do it on my own? I don't know why. Okay, if you increase the sample size from 60 to 80, what do you expect will happen with the width of your interval, confidence interval?
Wouldn't it increase?
I thought it's decrease.
There was a decrease.
I know the margin of error decreases with the more that you do, but I can't remember. I thought it increased with, but if your margin of error gets smaller and you're adding and subtracting to both sides, wouldn't that decrease as well?
Yeah.
I'm gonna put decrease.
Okay.
Unless you guys have some other, tell me. I don't
No.
know.
Decrease.
Okay. What do you think, Janine? Do you agree, decrease, or for 10?
I mean, I don't understand why though.
Because if you increase, this is my understanding, if you increase your population, right, or your number, you're going to get a more accurate likelihood of getting the right true mean, right? So then your margin gets smaller. And if you have a smaller number adding and subtracting to both sides, it seems like it would. But
Okay.
maybe not. I don't know. I mean, that was just my.
No, I feel like I'm confused. You guys all say decrease. I'm putting decrease for sure.
Probably
That
increase.
does make sense. That does make sense.
I know it says it somewhere around here. Let's see. Is there anything that's. I know it said it somewhere.
That's okay.
So if we get it wrong, we'll know. That's not right. Okay, let's go to the next one. 11. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1 over 2. What is the smallest number that can both requirements still meet? So P is 0.5, right?
Yeah.
And we want to find our number.
Point 5. Was it 2? Wait. No. Is it 20?
I got 20.
Okay. It's 20 then.
Okay. And so how did you come up with that?
Well, technically, you just put 0.5 times 20, then you get 10. And the smallest you need is 10.
Good point. You're right. Okay. That was easy. Maybe I just made things too hard. So if you haven't done the homework for this lesson, that's not on there because that would be easy. All right. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose the P is 1/10. What is the smallest n can be to satisfy both? Okay, so
Is it 100 then?
Yeah.
Mm-hmm.
Okay.
okay. Use the following information for the next 6 questions. These are the ones that I got messed up on in the homework too, because I would just like get one answer wrong and I just made all the rest of them wrong. Okay. So for the water quality reading, 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis test using the significant level of 0.5 with the following hypothesis. So they saying the P equals 60, P is less than 60. They collect new data. This time n equals 80 and x equals 38. Okay, so there's a test, there's a question like this. Only it never really gives you new information to work with. And so I was trying to figure out, like, do I need to go solve for p first before I apply it? I don't know, I could not figure out what I was supposed to do with that. Okay, so this is easy. We have, okay, so again, so this is, we're doing the hypothesis test. So this is where we're going to use the regular p in the standard deviation, right? Whereas this one, we're supposed to apply it to this lovely little thing here called the Excel. Okay. If I put that in, okay, so question 13, conditions of the hypothesis test are satisfied. I'm going to say yes. Do you guys agree with that?
Mm-hmm.
Okay, 14, what is p hat rounded to the next 3 decimals? So 0.633. Okay, so what did you guys get for 14? Okay, what do you guys have answers? I just tried to plug it into this Excel format and see if it.
Am I gonna take a shower right now?
No, I don't care.
Because good. I'm being.
Okay.
We have a shirt I can use as pajamas. Can I use these as pajamas?
No, not right now. Can you go out?
I know because I need to take a shower. Can I use these as pajamas?
No, you can use your own. Sorry, guys. Hold on.
No, she's taking a bath in her room. And the sink.
Okay, here. Here. All right. All right. Stop sleeping. Okay. All right. So what did you guys get starting with 13?
Where did you find the SL one? The spreadsheet thing?
So the spreadsheet. So it was in lesson 17. It's called Categorical Data Analyst.
Lesson 17.
Yeah.
It's under the individual prep thing?
So it's, let me see if I can find it really fast. So there is a link to it. Let's see. Okay, so go up to 2.3 on lesson 17.
Wait, what do you mean by 2.3?
Well, if you look at, like, if you go on the lesson of 17, and each one of the bold types are numbered like 2.3, 2.4. Section 2.3, it says using Excel to perform these calculations. So it's like 1/3 down from the top. Maybe 1/4 then. It's in the lesson.
Okay.
Did you find it?
hmm
Okay. Oh, I need to change that. Do you know what? Mine is probably wrong because I didn't. This P hat is totally different than. Okay. That isn't open. Okay, if you put the information correctly into the Excel, it works better. Okay, what did you guys figure it out or find the? Okay, what did you get?
Zero 0.632.
0.633.
No, because if you look back up, they collected new data. This time N needs to be 80 because I did the same thing and I put 60, but N needs to be 80. So change that to 80. So then I got 0.475.
For 14.
For 14, I got the P hat, right?
Yeah.
And so I got 0. So if I have X is 38 and I have N is 80 and my confidence level at 95 and my null I have at 60 or 0.60. And I'm saying that it's less than, right? Or am I?
Yeah.
That makes my P hat number 0.475.
Okay.
Yeah, that's right.
And then that makes the test statistic negative 2.282. And that would make the P value
Is it
0.
0.0112?
Yeah. And so so then the next question, what is your decision for this test?
Would you reject it?
I would say we reject the null because it's less than 0.5. Okay, which of the following best summarizes the conclusion of this test? There is sufficient evidence to conclude that water quality in the area. Oh, no, that can't be right.
Is it the third one?
Well, if we reject it, though, aren't we saying something against the null? We're saying that there is sufficient evidence to conclude that water quality in the area is decreased.
Okay, yeah.
Like the last one.
Yeah.
Don't totally listen to me, because these were the ones that I missed. I missed every single one of these on the test. I chose the wrong one every time, so I'm not the best one to answer that. But I think after doing some extra studying, I'm trying to sort it out in my head. I'll tell you what, I will go and submit it and let you know how we did. Okay, so we did fabulous. We got 100.
Oh.
Now we just have to sort out the whole study thing and get that submitted by Saturday. Okay, so I'm going to be straight honest, and I don't want to be the one that like is a slacker because I really don't want to be, but I do not think that I can write up the design study with all of the distractions that I have around here. I mean, I've been working on this for like 3 hours trying to figure out why I screwed up the homework quiz and only got 27%. So my head is not in the game. And I would hate to risk that with you guys as well, as far as turning in this study design. So I'm trying to find, didn't he have a sheet like we were supposed to download and fill it out or something? Like, I'm happy to help come up with ideas, or we could try to kind of rough draft it together and then have somebody really smart out of all 3 of you write it up and decide which parts we're going to do for the rest of it. Let's look at design study instructions.
Okay.
Number 16. And we can go to design the study and open it up. I also don't have access to a printer right now. I guess I don't need one. Nice. Okay, this is a group project. Everyone in the group is responsible to help create and edit each document associated with the final project. I would suggest creating a Google Doc in which every member can add and edit the document. We could do that.
Yeah, I think it would be easiest if we create a Google Doc.
I think so too. And then I wonder if we could just transfer this over.
Yeah.
So, listening. Okay, so who feels brave to help us write up the design study? So you're to create your own design study based off of the interests of the group. Did anybody think of any other ideas that we could use?
I like the bread idea.
Okay, because I'm totally open to anything else. I was just brainstorming. I feel like I was getting ahead
No,
of you.
me too.
You guys like the bread idea?
Yeah.
Okay.
Yeah.
I think, yeah.
Okay, what is our research question? I think I'll write a rough draft of that. I'm going to put it in maybe dark orange or something, to bright blue maybe. Okay, so this is where we need to kind of like formulate. What about if we did, does the same kind of bread cost the same amount no matter the location? Or is the same kind of bread, can you buy the same kind of bread for the same price online anywhere in the country? Or, I don't know, what do you guys think? How do we want to do the bread?
If we do it anywhere in the country, does that mean we're gonna have to get it numbers from like every state?
Yeah, we would have to get numbers from every state, but we could choose 5 from every state. We could choose 10. We could find the zip codes, or we could say, does the same bread cost the same amount at Walmart, rather online or in the store? And we could check out all the area Walmarts and then look online for all the same areas. Surely they are, but somebody once told me that depending on your area, that certain items are cheaper if it's a more impoverished area than if it's in a more affluent area, that prices are slightly increased based on the area. I am in school. So I don't know, that's just kind of where I always wondered if that was true or not.
I think it's interesting. I think we should
Or we could do a package of cookies. I wonder if cookies would be something that you could get like chips. No, well, I don't want to say Chips Ahoy because that's right there, but like sugar. I don't know. What do you guys? Okay, I'm gonna do a share screen for right now, and then we can look at this and kind of type it up. So I got this. Okay, can you see that?
yes.
Yeah.
That's the wrong one. That's the lesson. Don't look at that one. Where's my other one at? Well, we'll just open up this new design study because I don't know where it went. Okay, so here, how about that one?
Yeah.
Okay, so
Yeah.
I'll put our names in and I'll make it a Google Doc.
Okay.
So what should we could just kind of rough draft it right here and then we could all go back and kind of edit it along the way.
Perfect.
Okay, so I'm going to change the font just so we know that this is what we're, for the color anyways. Okay. How do you guys want to do local? Do you want to do local, just like all random stores, or do you want to just focus in on one, like Walmart, and we
I
could,
think we should just focus on Walmart. That's the easiest, and
okay.
we can find that location.
Does the price of bread change depending on location? Analyzing local and online sources. It's really easy to go on to walmart.com and
Yeah, exactly.
they have a whole, like we could just divide up 50 states between, that's like 10 states each, and
Yeah.
we could do 5 from each state. That would give us a lot of data. And we might have to do like 13 or something like that. I don't know what 50 divided by 4 is right now, but I'm sure it's not that much. 12.5, 12, something like that. Okay, depending on location, using online and local Walmarts. Walmart. Online shopping across the country. Population that we're studying.
It would be
The bread prices.
wouldn't it be the bread prices in the United States?
There you go.
Mm-hmm.
Okay, what is your experimental unit? I guess that we need to figure out what kind of bread.
Yeah.
What kind of bread do we want to do?
Grandma Sycamore.
Okay. How do you spell sycamore?
Sycamore.
And then we could put or similar brand. I don't know if they have that in Maine. Or maybe we could change it up and it could be Wonder Bread or something. I don't know. Somebody Google most popular bread in the United States.
I will right now.
I haven't seen Wonder Bread up here in Utah.
I've never heard of Grandma Sycamore.
I never heard of any grandma bread until I moved into northern Utah.
That's what's really popular up here. I don't have Wonder Bread down in.
Yeah, I don't think Wonder
Or-
Bread's everywhere anymore. Most popular bread.
Or is it Sara Lee bread? I don't know.
Oh, Sara Lee.
I'm just trying to think of something I've seen around.
What about yeah, so King's Hawaiian is number 1, Wonder Bread, Sara Lee, Arnold's. That's the one I see a lot. I don't know if that's everywhere though. Oro Wheat.
I know. We could look up 2 bread prices. We could look up 3 different bread prices, I guess, and whatever one gives us the best data. Then. Okay, so what were the would be the units? Wonder Bread. Let's just do 2. Wonder Bread and Sara Lee.
Apparently.
It says Wonder Bread is back in stores. Yeah, I think Wonder Bread and Sara Lee.
Okay. Or in other words, what is the smallest entity from which you are collecting a single piece of data to be used for analysis? Well, I don't know how to answer that other than Wonder Bread and Sara Lee. And then we can say at 5 online locations in every state. And we could randomly pull zip codes for each state, like our list of states.
Yeah.
We could, like I attached at one point, like the list of zip codes, and we could cut and chunk and then just pull out and look and see if there's a Walmart in there that has, that would be random. All right, in other words, the smallest entity. Every state. 5. Okay, what is your response variable? In other words, what is the variable of interest your experimental user is responding to? The price of bread. Right, unless I'm.
Price of bread, yeah.
Or is the variable isn't the price of bread, is it the location? Is that what's variable?
Yeah, actually, you're right. Wait, wouldn't they both be variables?
We're measuring the bread, but we want to know if there's a price change by location. Location. I think it's the location. The response variable is location. And the price of bread. In other words, what variable experimentally responded to. If you were interested in an average difference in the number of shoes owned by a female college student versus male college students, the response variable would be the number of shoes. So we're interested in the price of bread, right? What do you think, Nan?
Yeah, I think you're right.
Is our response variable quantitative or categorical? I think it's quantitative, isn't it? Because we're looking at numbers that we can.
It's It's quantitative.
Quantitative.
Okay. Okay, what statistical method are you going to use for your study? I have no idea. To independent or dependent? Or are we comparing one? Or is it just one sample, sigma unknown?
Or mhm.
There's going to be lots of locations that we average out of one item.
What if
Unless
it,
we wanted to break it up like the north or the
Well-
east and the west or something.
what if
I
it
don't know.
ANOVA?
Quantitative or 3 or more samples. I guess if we did 3 or more samples, we could add a different bread and do Arnold's added to it.
Oh, I was thinking about location.
No, and do like 50. I don't know. What do you guys think?
I don't know for this one.
So are the bread brands our samples?
I don't know. Should we think on this? I'm not really sure. What are your null and alternative hypotheses? Okay, this one's easy. Price of bread is the same
Everywhere.
everywhere. So that would be HO, right?
Yeah.
H
The alternative.
O. Okay, so HA. So the alternative would be the price of bread is different. Or we could say the price of bread is, we could divide it into, we could do NOVA, ANOVA, and we could do the East, the Midwest, and the West Coast, and divide it, and we could say it, and have data for, and then do a comparative. I wonder if you could use different ones, like we get the data
Yeah.
and we represent it in different ways. The price of bread is the same everywhere. The alternate hypothesis is the price of bread is not equal.
It varies. Depending on location.
No, what about that? Okay, design the sample. Which sample method? You guys need to go.
When's this due? This is due Saturday.
Yeah. Hopefully, see, I didn't want to go through human subject committee. I was like, I don't want to do that. I don't want to do any more paperwork than I have to. Okay, is your project approved? Your instructor will give. So we have to turn this in. Survey approval, but we don't have to do that.
You guys want to meet again?
I could meet Saturday anytime.
I'm gonna be out Saturday.
I'm leaving out of town Friday night and I'll be up in the mountains, so I don't know if I'll have service.
What about tomorrow? Do you have before you leave?
I can during the day.
What about you, man?
What time during the day?
I know what's good for you, Lauren, because I think you're the one with the worst schedule.
Yeah, Friday, okay.
As long as it's before like 3 o'clock.
I can do that. I can do. You guys want to do 2?
Okay.
Can you do that, man?
Yeah.
Okay.
Okay.
I'm gonna set an alarm on my phone, and if I'm not, somebody text me.
Okay.
Let's try not to miss this one. Okay, 2 o'clock, and if anyone needs to change it or do earlier, let us know. I'm pretty open tomorrow. I have something in the evening that we're doing, but other than that, I'm pretty open.
Okay.
Yeah. I'm just leaving at 3, so anytime before that's good.
Are you going to be packed and ready, or do you want to do it earlier so that you have time to make sure you load the car and you're ready? Do you want to do 1?
I'll be packed and ready. It's camping, so I don't have to pack anything.
Okay. So let's make it 2 then. Okay, I'm gonna end this broadcast.